Okay, ladies and gentlemen, we're now going to be looking at the asymptotes for this function. Totes. And I think it's number 4 in our list of characteristics that we look at. So let's look at vertical asymptotes. They're going to occur when this is dividing by 0. So when x squared minus 1 equals 0, so you're going to have two vertical asymptotes, one at plus 1 and one at minus 1. So you're going to have a situation where we're going to have something coming like this and something coming like this. They should be roughly equally spaced. Vertical asymptote x equals -1. Vertical asymptote x equals 1. And what we need to do is find out what happens as our curve is approaching this way, this way, this way, and this way. So you're going to use limit charts, and I'm not going to waste time here doing it. I've done it myself 1,000 times. Let's look what's going to happen. So we're going to be looking at the limit as x approaches -1 from the left of f of x. That's what you're going to have to figure out. You're going to want to figure out the limit as x approaches -1 from the right of f of x. You're going to want to figure out the limit as x approaches 1 from the left of f of x. And finally, the limit as x approaches 1 from the right of f of x. What I can tell you is that I know what these are, and I can tell you that this one is going to -infinity. This one is going to positive infinity. This one is going to -infinity. And this one is going to positive infinity. So what you're going to have is you're going to be looking at a curve that as I approach -1 from the left, I'm going this way, I'm going this way, and this one I believe is this way, and then this way. How do you figure that out? You take a chart, you take all the values of x less than 1, you take f of x. You need to be on the left-hand side of -1, but getting closer and closer to it, and then you plug those values in. What you can tell is there a shortcut way of doing this? I don't see anything terribly shortcut in doing this. Maybe some of you can, but as x is getting closer and closer and closer to -1, let's see here. 1.1 squared, take away 1. So this bottom is going to get smaller and smaller and smaller. The top is getting smaller, but is it getting as quickly smaller? I wonder. Let's see. No, the bottom's getting smaller faster, so maybe that's one way of thinking about it. But anyway, you can work out these values and you're going to find out that it's going to go to -infinity. Maybe looking for a shortcut, you can tell that 1.1 is going to take away 1 is going to get smaller and smaller and smaller. This top part is getting smaller, but not as quickly. And it is going to be negative because we're going to have that's going to be positive, subtract 1. Let's see. Yeah, the bottom's going to be positive, the top's going to be negative, so it's going to -infinity. Again, you guys can figure out what you want to do, if there's a shortcut or not, or just put in the values. So those are your vertical asymptotes. Let's take a look at horizontal asymptotes. Horizontal asymptotes occur, there's no E in occur, when the limit as x approaches positive or -infinity of f of x equals a constant. Okay, that's by definition a horizontal asymptote. It's at the extremes of the curve. So we'll take our limit and we'll take it in terms of positive or -infinity of x over, what's our function? X squared minus 1. We're going to divide top and bottom by the largest power of x squared. So it's going to be x over x squared equals x squared over x squared minus 1 over x squared which is going to be the limit as x approaches plus or minus infinity of 1 over x over top of 1 minus 1 over x squared. Let's see if there's a difference. If I apply positive infinity, that goes to 0 over 1. Negative infinity, that still goes to 0. There's no difference in the sign. So what's happening here is both of these are going to 0. And what that means is that we have a horizontal asymptote when f of x equals 0. And it's in both directions. In both directions. So what that means is as x approaches positive infinity, f of x is approaching 0. And x is approaching negative infinity, f of x is also approaching 0. So what we have is, so we've got a horizontal asymptote here. It's actually on both ends. If we want to know if we're approaching from above or below, we could take a test point. So we could plug in f of negative 100. What you'll end up with is negative 100 over negative 100 squared minus 1. If we think about that for a minute, that's going to be a pretty big number. Take away 1, it's definitely going to be positive. The bottom's going to be positive, the top's going to be negative, so we will be approaching from the bottom because a negative number will definitely be less than 0. So this is going to be less than 0. Over here, if we plug in a positive 100, we're going to get 100 over 100 squared minus 1. The bottom is definitely going to be positive, the top is positive, so it's definitely greater than 0, so we're definitely above. We can only do that with 0 because our horizontal asymptote was 0. Had the horizontal asymptote been 5, I would actually have to work this out and make sure that it's above or below 5, okay? So keep that in mind. And that is horizontal asymptotes. We'll leave that and we'll be back in a minute.